When you hear the word robot, you've probably got a picture in your head, right? Something metal, clunky, full of gears and motors. Well, today we're going to throw that picture out the window. We're diving into a totally different world, one that's flexible, adaptable, and a lot more alive. Welcome to the incredible world of soft robotics.
Okay, so let's unpack this. For the longest time, the whole game in AI was to build machines that thought like a super formal logic problem. You know, step by step, rule by rule. But as you can see here, researchers started hitting a wall. They realized that approach just couldn't capture the messy, intuitive, and frankly, human way we all navigate the world. And this led to a huge light bulb moment. People started asking, hey, what if we're looking at this all wrong? Maybe the issue wasn't just about writing smarter code for a metal box. Maybe the metal box itself was the problem. What if the answer was something, well, softer, both in how it thinks and what it's made of?
That one powerful question kicked off a revolution. It gave birth to this whole new philosophy, championed by people like Rodney Brooks, called soft computing. And believe me, it completely flipped the old way of thinking on its head.
So, what is soft computing? Well, instead of trying to program a robot for every single thing that could possibly happen, you just let it learn. It uses its senses to make pretty good guesses and adapt on the fly. Think about how you walk on a rocky beach. You don't calculate the angle of every single stone, right? You just adjust, you balance, you feel your way through. That's the big idea.
And here's where it gets really, really cool. This whole idea of softness didn't just stay inside the computer. It literally leaped from the world of software into the world of hardware. It started to change not just how robots think, but what they're actually made of.
Which brings us right to the heart of it. If you want to build a truly soft machine, you don't go looking for blueprints in a car factory. No way. You look at nature's playbook. You look at the best soft machines ever designed, living things, all the way down to a single cell. I mean, just think about an octopus. No bones, no joints, but it can squeeze through a hole the size of a coin. How does it do that? It's not gears. It's all about managing internal pressure inside its cells. So researchers zoomed in on that exact mechanism, how fluids moving around inside a cell can create incredible change. Now, I know this looks super technical, but don't get hung up on the jargon. The main takeaway is actually pretty simple. All this is saying is that if you can control how fluid moves around and creates pressure inside a soft bag, you can control its shape. You can make it move. That is the whole magic trick. It's movement without motors. And here's the recipe for how it works in the real world. You start with some kind of squishy material. You put little fluid-filled pockets inside. Then you just pump that fluid back and forth. And that's it. The pressure changes do all the work, making the robot bend, stretch, and crawl. It is so elegant, and it's all done without a single solid gear.
So let's put these two ideas, the old and the new, right next to each other, because when you see them side by side, you really get a sense of just how huge a leap this is.
Look at this. On one side, you've got traditional robotics. It's rigid, it follows strict rules, and it works great in a totally predictable place, like an assembly line. But on the other side, you've got soft robotics. It's flexible, it learns as it goes, and it's built for the messy, unpredictable world that we all actually live in. One is about forcing order on the world, the other is about learning to flow with it.
And you know, this shift from hard to soft isn't just some cool engineering project. It completely changes the conversation about our future with robots and what that future might look like.
We've all heard the big warnings from people like Stephen Hawking about a rogue AI. But that fear, the image of a cold, calculating machine that might see humans as an obstacle, that fear was born from the world of hard robotics. It's a fear of pure, cold, rigid logic. And that's the big question soft robotics leaves us with. What happens when the smartest things we build are no longer cold and rigid? What happens when they're soft, squishy, and learn about the world by feeling their way through it, a bit like we do? Does that change the entire game? It's definitely something to think about as these amazing, lifelike machines keep evolving.